Welcome to the Copernicus Data Space Ecosystem webinar with a focus on Copernicus Browser. In this webinar, Andrzej Zlinski will introduce to you the advanced use of the browser, how to do advanced visualizations, data analysis, and more. To follow today's hands-on webinar, we invite you to register to the CDSC if you haven't already, of course. You can do so at dataspace.copernicus.eu page by clicking on the person icon in the top right corner. So without further ado, Andras, the floor is yours.
Hello, everybody. Welcome to Copernicus Data Space Ecosystem and to this webinar. This is an advanced course, so we are assuming that you already know how to do basic image visualizations, downloads in Copernicus Browser. If you don't worry. We have a video tutorial which will be also linked to this recording. So Copernicus Browser is aimed to be a free and open intuitive viewer. The purpose is to make it easy for people to look at satellite imagery and perform basic analysis tasks. We want to show you how to work with configurations and theme-specific Evalscripts, how to work with pins, how to use the Copernicus Data Space Ecosystem display wall, how to create comparisons, how to generate sharing links, how to upload or download areas of interest and to use these for quantitative analysis. We will explore the 3D view together with its settings, and I will show you how to work with custom scripts or custom Evalscripts, as we call them. This course is designed to be followed on your own computer, on your own laptop. To help with this, we plan to post the sharing links of each individual scene that I show in the meeting chat. So if you can't follow for whatever reason, just wait for the next link, click on it, open it up in your browser, and then you will be back on track. So this is Copernicus Browser. This is the basic interface for looking at the map. This is the map canvas. Here you can select an image date. And once you have an image loaded, you will see various layers that you can use for visualization. But this is the default setup of the browser. Actually, we have a couple of what we call themes and configurations, which are specific for various applications. Let me give you an example here. This is a place close to Lissa in the Netherlands. We have blooming tulip fields here. And the configuration which we are seeing is called Monitoring Earth from Space. You see there's this drop-down list in the configurations panel where you can select various configurations. And these come with a specific collection of scenes or pins that you can explore. But additionally, if you just load the latest image, you have a collection of visualization layers which are different from the default layers. There are more than what you get in the default, and these are specific for the theme that you can explore. So for example, in this case, you can also look at the agriculture theme. Again, we load the latest image. For agriculture, I think it's only offering Sentinel-2, but here you have a false color visualization available, which is the near-infrared false color, also available in the default panel. But for example, enhanced vegetation index is only available in this particular configuration. So if you are interested in a specific application of Sentinel data, probably the easiest way to explore different visualizations in different data sets is to go to the configurations panel and select one of these configurations here. It's also possible to create individual pins, specific locations, similar to the ones which we have here in the configuration panel. It's very easy to do this because it goes directly from the main menu. So what we have here, this is actually a place in northeastern Hungary near Oktelek. It's a karst region. You can see the topography features. It's a relatively recent image. So if you want to create a pin out of this scene, then all you do is you click Add to and Add to Pins. And then if you click on the Pins panel, you will see all the pins that already exist. For most of you, this will probably be empty unless you already have some pins. And here you have an option to name this pin. And actually even to add a short description. Which will display if you show the pin. Now in this pins panel, it's also possible to share these pins, to export them in the form of a JSON file, or to select an individual pin and export that one, or to import pins from somebody else's collection if they are sending them to you. And these pins are an opportunity to go back and visit the same places or to look at your favorite images or your favorite scenes. But there's an additional application for them, and this is the CDSC display wall. The CDSC display wall, I've launched it just to wait until it loads, yes, is an automatic slideshow view of all the pins you have created. The use case actually for this is typically at a conference stand or an education fair if you want to show a series of images that relate to a specific topic or they are just pretty. You can create this automatic slideshow. It's going to import all the pins you have. You can switch between them manually, or you can also set the timing for an automatic switch. And within this display wall viewer, there is also a small embedded sort of light browser. This allows you to search for a specific place and open up the latest few images and view them on a very easy interactive browser. This is designed in a way that it also supports a touchscreen, so the controls are very simple and the visualizations are limited. But it's a very quick option to explore satellite images. Actually, I found that it works really nicely also on a smartphone. So since that also has a touchscreen and the controls are not that complicated, it's a quick way to show satellite imagery to your friends. Now I want to show you how to compare images. Again, when we work with satellite imagery, one of the really popular applications is to show somebody what happened, how change happens, because you can see it with your own eyes. Here we are at the Monte Sarmiento in Chile. This is an image from May 2024, so end of the summer season actually, or autumn season over there on the southern hemisphere. And we can explore how much the glaciers have changed over the last 4 or 5 years. So the way we do this, again, we go to the Add To button. This time we are adding it to compare, right? Add to compare, and then the number appears here. And now we go over to the calendar panel and we start going back in time. Let's see how far we can go back in time. We can definitely go back to 2016. And we're trying to find a cloud-free image of the same place. Yes, this is quite cloud-free in 2016. And we click Add to Compare again. And now, if we go to the Compare panel, you will see that these two images are loaded, one above the other. So right now, 2016 is on top. 2024 is in the bottom, but you can just grab and rearrange if you want. And then with this control, you can swipe from one image to the other, just separating one part of the screen, showing the new image and the other showing the old one. Or alternatively, if you select the opacity effect, then again, you are changing the transparency of one layer above the other. And this gives you a really, really nice view of the processes that are happening. Now, actually, in a similar way to image sharing, it's also possible to share the comparison itself. Actually, let's go back first to a single image. Let me show you the opportunities for sharing an image. So we often share images, of course, in social media where we just download an image and we send it to somebody, but it's possible to generate a direct link to every scene that you see in Copernicus Browser. If you just click on this share icon and you click Generate, here is a short URL. And if you copy this and paste it in a different browser, it's going to open up the very same scene. So the same image, the same visualization layer, the same data source. And this allows you to actually verify the images that you send to people or the images that you post on your social media, since anybody will be able to look up that actual image and to see it in our official browser. It's also possible to share images in Facebook or Twitter or LinkedIn with the very same scheme based on the sharing URLs. And this function also works for comparisons. So if you click Share here, it's going to generate a link. And if somebody is already logged into the browser and they paste this link into their browser URL row, then it's going to take them to a comparison scene with exactly this level of opacity applied. So again, if you want to show how a process is happening, this is a very, very easy way to share the information and to make it possible for anybody to export there or to view what you're exporting. Coming back to the main browser view, I want to show you effects and advanced options very quickly. This is a small control surface to tune the visualization of your image. So you can adjust gain and gamma. You can adjust the color balance a bit. You can change the mosaicing order if you're looking at an image mosaic. And you can adjust the upsampling and downsampling of the image. So you can actually remove the smoothing that happens in the image, and then you get a bit more blocky pictures, but they're actually closer to the data that's seen by the sensor. Let's give it a second until it loads. If I zoom in now, you can see that the pixel boundaries are sharper. The image has less of a smoothing. Now I want to move on to quantitative analysis. So what we want to do is upload an area of interest and do a quantitative check of a process. Here on my screen, I have Sentinel-3 level 2 land OLCI chlorophyll index product loaded. So this shows you the amount of chlorophyll in vegetation. It's a quite a recent image from the 3rd of April. I'm removing the labels just to make it easier to see what we have. And so to create an area of interest, we are using this tool. One option is just to draw a rectangle. This is quite easy, and once you have the rectangle, you can generate a time lapse or a time series graph. So for the last 1 year, you can evaluate how this chlorophyll index has changed in this little area in northern Germany. The blue line is the mean, and the light blue background is the standard deviation of the value. So when this is happening, the API is querying all the images from the last 1 year which overlap with the study area, and it's calculating this index. But it's not only possible to upload an area of interest by clicking a boundary. You can also upload it directly as a JSON using this little tool here. So what we are doing here is a source of free GIS maps. It's possible to download the boundary of Germany in the form of a GeoJSON. I've done this before the webinar just to have it ready. And I can take the file and just drag it onto that little browser field. And if all goes well, it's going to upload, yes. And here we have the national boundaries of Germany. So this is quite a complex area of interest. Of course, it has a couple of hundred vertices, but even for this area, it's possible to generate a time series in the similar way. And of course, for individual points in time, the mean and the standard deviation is not always sufficient information. Maybe you are more interested in the heterogeneity within your area. And for this purpose, it's possible to generate a histogram. I will show you in a moment when this has loaded. So this is the 1 month time series. Of course, it would be possible to load it for a longer period, but that would take some time to load. So with this tool, you can calculate the histogram. Again, it's going to show you the variability of this chlorophyll index within the territory of Germany. One small point I forgot to show for the time series graph, it's actually possible to export the data in the form of a CSV, so you can have tabular numeric data from these time series graphs that you can then further work with. Now I want to show you how to generate a time-lapse image. We're moving on to the next place. This is Frampton Marsh in the central western UK. So it's a tidal wetland, and the shape of the vegetation and of course the amount of tide at the specific point in time when the satellite passes over changes a lot during the year. So the way we explore this is by generating a time lapse. This is a very popular feature of CDS Copernicus Browser because you can actually generate a moving image that's very easy to interpret. So what you do is you just click on create a time lapse animation. It shows you the area that is going to be included in the time lapse. And then you have to select a start and end date. Right now I will go for 6 months. So we will go back to October 2024. The images that are framed in blue are the cloud-free images. We select one of them. Now we have this period, and we can then decide how many images we want, whether we want to look at every single image or an image a day or an image a week or a month or a year. I'm going to select an image a week now. We only want the images which cover all of the area in this little frame. If we would reduce this, we might have an image that sort of cuts across the scene and only shows half of it. This is where we select the cloud coverage threshold for the images that we query for this time lapse. And now the API is running again in the background, and it's selecting the pictures that it will include in the time lapse. So now this little search is done. We have 2, 3, 4, 5, 6, 7, 8 images, and I can run this animation here. You see how sometimes the river floods, how the sediment dynamics change, how the vegetation changes. This is a simple time lapse of these 8 images. Now I want to stop the animation because I'm changing the controls. Of course, you can increase the speed here. You can also decide how the transition should go, whether it should fade or just flick between one image and the next. And it's also possible to adjust the size of the output image, to change the fade duration, or to delay the last frame, which is actually a nice thing because then the looping effect is somewhat reduced. You can download in a GIF or an MPEG video. All these options are available. If you want to look at a longer time series, let's see, now I'm going back to October 2022. It's possible to filter the images by month. So now I only want to look at winter images, for example. I'm taking out everything between March and October. And I'm selecting one image per month just to avoid overloading the system. And here again, the query is done. I can run the time lapse and see what has happened in this period. Actually, a time lapse is a really nice tool for simply searching whether something interesting has happened in a particular frame, because the date is on the image. So if you see something that you want to explore in further depth, you just stop the animation and then you can go back and select that date, 2023, 21st of January in this case. On the main screen and zoom in and explore further. Now we are moving into 3D visualizations. So fasten your seatbelts, we are going to fly. Again, this is a very popular application of Copernicus Browser. I think 3D perspective data is always very cool. The underlying elevation map is the Copernicus 90-meter global digital elevation model. So it's not super detailed, but it works globally. So for example, a landscape like this, where we have Mount Whitney in the USA, is a lot easier to interpret if 3D visualization is available. Because here, I mean, the shadows help you understand the topography a bit, but it looks a lot more interesting and shows you a lot more detail in 3D. So you just click the 3D view button here. It takes a bit of a while to load because, of course, it's rendering the data now on top of the terrain model. And then the controls are the following. With the left mouse button, you can pan. With the right mouse button and moving the mouse backwards and forward, you can zoom. And with the center mouse button, so the scroll wheel, you can tilt and rotate the image. So now the 3D view allows us to explore the landscape a bit further. And what actually happens when you switch from 2D to 3D, I can show this again, is that the scene that you have on screen, this is what is going to be loaded into the 3D viewer. So it's worth selecting a relatively large area, because then you will have less gaps in the 3D visualization when you load the data set. Again, I'm giving the system a bit of time to load. Now I click 3D. And now everything which I have on screen on the 2D view is going to be loaded and rendered in 3 dimensions. Again, this takes a bit of time. I can zoom in to help with this. Whoops. And now if I just rotate in, you will see the steep eastern wall of the high Sierra in the USA. Let's explore the controls a bit. Again, here you can zoom in and out. Here you pan left, right, up and down. You can also change the compass heading with this little button here. With these controls, you pan the image. And then here, you can set some parameters. Let me roll this further down so you see the sky. So there are several sky effects depending on which direction you are facing. You can remove the camera effect. You can remove the atmosphere. You can change the parameters of the sun projected shadows, which are calculated based on the elevation model. And you can also change the parameters of the shading. There is a shading algorithm which calculates from the elevation model the areas which will be shadowed. And then these can also be adjusted depending on what brightness of the surface you assume and how you prefer these shadows to be done. The most important control factor for 3D views is vertical terrain scaling. So you will see that it's possible to overemphasize the terrain. And then you see a bit more. Actually, this is really striking if you have relatively flat landscape. You can change the control mode because you can like click a point and rotate around that point if you add this option. And it's even possible to export anaglyph stereo images. If you have glasses with blue and red left and right lenses, then you can export an image or view the 3D with this anaglyph mode. I'm resetting the values right now to the defaults. And then here, it's also possible to adjust the terrain lighting by removing the sun shadows. Then you're only seeing the shadows which are there naturally in the satellite image. And here you can change the sun time. So depending on the location of your virtual sun, you will see different shadows generated from one point to the other. This is actually a really handy tool if you're going to the mountains and you want to watch the sunset, or you want to design your hiking route according to always being in the sun. You can adjust the date and then adjust the time of the day accordingly. So this is again a fun little tool to explore. Right now it's the late afternoon over there. No, it's the early morning over there. Okay. It's also possible to download images. We only have the basic download, so the resolution, I mean, it can be tuned here, but it's the default settings are not particularly detailed. You can select several formats, and you can download various images. Now, there's one final trick I wanted to show you with 3D scenes, and this is to use the quarterly mosaics. So here in the data collections, normally you load the Sentinel-2 individual images, and I can show you the latest image again with a bit more detail. Some of it is going to be cloudy, and the image has a well-defined edge as the satellite passes through the orbit. Give it a second to load. Yes, here's the edge of the image, right? This is one of our main limitations. But if we use quarterly cloudless mosaics, these are generated as a mosaic of the images that are collected within a full month. So they are completely cloudless. They are completely seamless across the globe. And therefore, it is possible to create quite wide-ranging visualizations over large areas, loading the data without the edges or the gaps. So I have always found that unless you want to visualize a specific point in time, these quarterly mosaics are a lot better for 3D visualization. Again, I'm giving it a second to load. And then here you will see that the area which is covered by the mosaic is a lot larger. And so you get much nicer, much more compelling illustrations in 3D. Now, the final step of this course is working with custom scripts. For this, we are moving on to the city of Hamburg. This is a true color visualization from a recent image on the 3rd of April. So what you see here, we have these individual visualization layers, but down here we also have an option to create a custom composite. So with this simple interface, you can drag and drop the individual bands onto the red, green, and blue layers of the visualization script. So what you do is you take one of the bands of the Sentinel satellite dataset and you assign that to the red, the green, or the blue channel of the satellite image. So here I've assigned the shortwave infrared band 11 to the red, the near infrared band 8 to the green, and the red to the blue. And you will see that a lot of different parameters are highlighted. The differences in vegetation are a lot more striking. So this is a very simple option that allows you to explore different parameters of the image. You can do the same thing with an index, actually, assigning just 2 different bands to this simple index, taking the difference and the sum of the bands. And then you can also explore various parameters of the data set. I'm going back to the composite now. Because the next thing I want to show you is what actually happens in the engine room. So now we've generated a simple composite. Yeah. No, like this. And inside, what we've actually done is here in this code window. So this is the heart and soul of the visualization. This is what we call the Evalscript, or the custom script. It has 2 basic parts. This is the setup function, where we tell the system which image bands we are going to use, what the input and the output is going to be. And this is the evaluate pixel function, where we actually tell the machine the calculations that should be taking place during the visualization. The output is 4 bands because they are red, green, blue, and transparency. And then here we have 4 outputs: band 11 multiplied by a scale factor, band 8 multiplied by a scale factor, and band 2 again multiplied by a scale factor. You don't have to generate all of these visualization codes yourself. This is JavaScript code, so it's relatively easy to edit. But we actually have a repository of these custom scripts, these visualization scripts, which are here for you to explore. I'm going to show you this repository. This is the Sentinel Hub custom script repo. And here we have a collection of scripts for various applications and various satellites, which you can load in a similar way. I'm going to show you how. My example is going to be a script called Magic Eyes. So here you see how the script works. It loads bands 2, 3, 8, 11, and 4, and the data mask. It assigns a gain function for brightening. It assigns a small weighting, creates a panchromatic image from 3 bands, and then it applies the gain to these 3 bands, 8, 11, and 4. Additionally, multiplying with the weighted panchromatic image to generate a small pan sharpening effect. So how this works, you just copy the code. You go back to your browser window. You select all of the code in here. And you paste it in and click apply. So once this is done, here's your image, which is now visualized with this little script. If I want to make an adjustment, I want to make it brighter. It's perfectly possible to change the code of the script to adapt it. And this way, you are really actually modifying the code which is governing the visualization of the image. And one final trick I want to show you, these Evalscripts are really capable of many, many different things, including applying a machine learning model or doing rule set-based classification. But what I'm showing you here is how to fuse multiple data sets. So what we have here is a flood image. We are actually overlaying 2 different data sets, one above the other. And this is done again with a custom script. The script is called Visualizing Floods using Sentinel-1 overlaid on Sentinel-2 imagery. And so the way it works is it has 2 data sources. One of them is the Sentinel-2 mosaic, which here is labeled custom. The other is the Sentinel-1 grid. And then it converts the Sentinel-1 data to decibels applies a threshold and the scale factor, and then it has a small if query. So if the VV reflectance of the surface based on the radar data is below a threshold, then it's going to return an image where the blue component is highlighted by a large multiplication factor. Otherwise, it's just going to return a true color of the mosaic. Let me show you how to use this. Again, you copy the script. We go back here. So this is Valencia. We are loading the Sentinel-2 mosaic from the 1st of October. Here we are. And now we are applying the custom script. So I click on the code button. I copy the code of the custom script. I click use additional datasets here. This is where I'm loading the Sentinel-1 grid data. So I click the plus. I click customize time span. And then I select this 30 to 31st of October date. I paste the code in. And now it loads correctly. So what you see is everywhere that's not flooded, we see the Sentinel-2 mosaic, and everything that's covered by water is highlighted in blue. This is how you work with Data Fusion custom scripts. Thank you for following this webinar, and I am still here for your questions and comments. Thank you.
Thank you, Andras. We have a couple of questions. We will try to answer as many as our time allows. If you have a question and it will stay unanswered, I invite you to use the Copernicus Data Space Ecosystem Forum for further communication. For the land use option, let's say agricultural, can we get also some written statistics calculations on what we see, like type, area in square meters, crop type, and similar?
Histograms only work for indices which have one single output. So where the output is a numerical value of an index, then you can apply the statistics API in the background and it can create the histogram. For classification maps or for red, green, blue visualizations, it's not possible to generate a histogram.
If several images fulfill requirements when generating a time-lapse with monthly time steps, which image is taken is then chosen to represent the month? So the chosen one is the image with the highest geometry coverage, so the biggest area, and the lowest cloud coverage, the least clouds. How can we convert file format from SAFE to TIFF? So the answer is when you download a product, you can find the TIFF within the downloaded file.
So I can show you again. Here we have analytical download. And here it's actually possible to select between several different formats, and this is the easiest way to generate a TIFF. Whereas on the other side here, with the search functionality, if you want to download the data from here, then you will be able to access the original raw data format files.
Santiago asked also, can you create a movie in 3D?
Yes, the time-lapse functionality is also active in a 3D view. So it's possible in the same way. It takes a bit more time to load and render, but it works.
From Jesus, we got a question. Let's say in case of uploading area of interest, is it possible to upload point type shape files or just polygon types?
Apparently that's not possible. Also, multi-polygons are not supported. So the browser is not really a full-fledged GIS. It doesn't support very detailed vectors, but it's possible to upload areas and lines of interest. But one thing that actually works is going to a specific coordinates. So in here, if you type coordinates in decimal degrees, it's going to pan the image to those coordinates specifically.
We have a question from Camille. If there are any plans to integrate Landsat data into the Copernicus browser?
Dino, do you want to answer that in more detail?
Yes, Landsat data is on the roadmap and it will be added in the next months.
Thank you. Then we have another question regarding the roadmap. Are there plans for adding more functionality to the browser? And if yes, what is the pipeline?
Well, we are actually going to release a user survey just in the next month where we will specifically ask for your wishes. So if you have a specific functionality in mind, we would really like to hear that from you, because we of course want to develop the browser in a way that makes it as functional as possible for you. We have been thinking of expanding these theme-specific scripts with more layers. We are also thinking about optimizing the controls further to use on small or differently shaped screens. I don't know of any sort of major big upgrade of functionality compared to this on the roadmap. We are looking more towards extending this with further data sets at the moment. Oh yes, there is. What we want to do is to integrate the OpenEO API with Copernicus Browser, and then you will be able to generate much more complex data analysis pipelines than you can in the custom scripts, and those will also be available for visualization in the browser. We don't have an exact timestamp, but this development is already planned.
Can we generate soil erosion time series hazard map in Copernicus browser, like using empirical model algorithms like Russell?
Yes, well, everything that you can code in an Evalscript is possible. So as long as you're not looking at neighborhoods of pixels, but individual pixels, you can code that into the Evalscript. But for soil erosion risk, we actually have an example notebook, and it's possible to do it in the Jupyter lab. Let me point you to this place just for a second. Here's the notebook. So if you're interested in soil erosion risk, maybe you can explore this one. There is a custom data set on slope, which is also integrated into Copernicus Data Space Ecosystem that you can use. It's a global data set. And then you can quantify vegetation cover using the NDVI time series and look at places which have a high slope and a lot of time of bare soil. This is the amount of soil erosion risk that we have been able to explore. But if you want to add a more complex model, we'd be interested to hear about it. And then this would be something that runs in an Evalscript. It would be, again, a data fusion custom script, just like I showed you with the flood mapping. And then it should be possible to visualize the results also in the browser.
Is it possible to load and visualize into Copernicus browser archived VHR images provided by the CCM providers? If not, is there any other method for this?
I think, but correct me if I am wrong, Dino, CCM visualization is also on the roadmap, so it should also be coming sometime in the next few months, because right now with Copernicus contributing missions, it's only possible to download them here using this tool. But we are already working on visualizing these CCM datasets directly inside the browser. But otherwise, if you have a custom dataset, it's possible to create a custom collection using the Bring Your Own Cog API, and then you can deploy that and visualize that in the browser through your own user account.
Thank you very much for the answer regarding the VHR imagery. I was curious if you can provide some link with the workaround, with the solution. Like, sounds a bit more technical, so if you can share something related to that, that would be really useful until it will be available within the Copernicus browser, as we asked. Many thanks.
I would start here. So this is our documentation page. This is the Sentinel Hub API, and here is the documentation for Bring Your Own Cog API. So this is where you would start if you want to upload a custom dataset and deploy it in the browser. You have to have a CrowdIAS bucket for it. But if you have that, if you're able to put the dataset to storage over there, then you can ingest it and you can visualize it in the browser.
Are there plans for allowing users to apply their own processing workflow for FX Sentinel-2 Level 1C?
Well, this is a bit of a larger topic because it would probably not work inside an Evalscript, but on the cloud platform of CDSE, or on one of the cloud platforms such as CloudES, it is possible to deploy your complete processing pipeline using our APIs, connecting to our data repositories, and then you can actually run a complete processing system on these data sets of your own.
Andras, there is another follow-up question for the name of the GeoJSON resource you mentioned.
Yes, it's simplemaps.com. I'm pasting it in the chat.
We can take one more question if there is any. Otherwise, we will slowly wrap it up. Let's wait for a couple of seconds. In that case, I would really like to thank you for your participation today. You're welcome to use our Copernicus Dataspace Ecosystem Forum for further questions. The recording of today's webinar will be published on our YouTube channel as mentioned, and all the relevant links alongside. So I would invite you to stay tuned and follow our social media for future webinars. And a big thank you, Andras, for your presentation, and to you for joining us today. See you the next time.
Thank you very much. See you next time.